Okay, so we're gonna videotape for our lovely students that are missing.
Our lovely nerds.
I think that looks pretty focused. Okay. Hello. All right.
Hi, how are you?
I was telling the story before about when you FaceTimed this class.
Oh yeah.
So cool.
To who?
All right. To my last hour. Trigonometry. Okay, so welcome back everyone. If everyone wants to take out your notes, we will continue our review process.
Somebody doesn't want their notes.
What was that?
It's like somebody doesn't want their notes.
Right.
Everybody wants notes for a midterm.
But I mean after the midterm, honestly.
Oh, yeah, I'm throwing everything away.
Yeah.
Why would you do that?
Their final exam is going to be on the same stuff as the midterm too. That'll be included.
I thought the final doesn't include what you do.
Yeah, we'll review again.
Yeah, the finals only
yeah,
the
those
other.
are your
The
notes,
final's only the
right?
second semester, right?
Your notes are on your computer.
Throwing away my whole thing.
You can throw it down.
I'm throwing
You
this
got
away.
it.
It's very silly. Okay. Do what you please. All right. I recommend you keep your notes. I still have notes from elementary school. I look back at them. 1 + 1 = 2. All right. Imaginary numbers. Oh, by the way, I changed your grades. I included the Thanksgiving packet for those that did it. I dropped an exam so you can see your grades. If you'd like. I'm pretty sure I put them in. They're your final grades for the quarter. Imaginary numbers. Square root of -1 is what?
Square root of -1, I.
Right? So I squared is
Negative
One.
one.
Negative one, that's what I mean.
I to the third is
Negative I.
negative I. I to the fourth,
1.
1. Very good. Now, what do I do if I have something like I to the 632?
Divide by 4 and the denominator depending on which it lands on over 4.
The denominator?
I mean the top, I don't know. The numerator.
The
Remainder. I mean the numerator of the part that you divide by 4, it corresponds directly.
Yes, you are.
Cool. So if the remainder is 1, it's this. If the
Hi,
remainder...
Harry.
Hello.
Is Tina?
No,
He's
he's inquired.
Are you good at life?
Okay.
You guys are supposed to know this.
Yeah, we usually get for a second. Just for your look.
Okay.
And then in the school, the yearbook thing, what I left behind, I'm gonna be like 1,000 cranes.
1,000 cranes.
My wish
So
was
imagine
1,000
1,000 cranes. This sounds like a short story or
It is a short story.
made
A haiku.
for
I mean, it is a book.
a motion picture. Okay, so look, if the remainder is 1, it's this. It's just I. If the remainder is 2, it's this. If the remainder is 3, it's this. If the remainder is 0, it's just this. Okay? It's not 0, 1, 2, 3. It's 1, 2, 3, and then 0. Because look, I to the 4th, if I divided that by 4, there'd be no remainder. So that's it, right? So 632 divided by 4. 4 goes into 6 one time, minus 4 is 2,
Good job, sir.
3, 5, minus 20 is 3,
Good job, sir.
32, 0.
Nice.
Hey, how about that?
I say yeah.
Cool, right? 150, so the remainder is what?
150, 0.
Remainder is 0,
Or 404.
so it would be
158.
I to the 632 is
1.
1. That makes sense, everybody?
Mm-hmm.
Guys got that. I'm also going to make these videos available somehow, I think on YouTube or something.
What's on your channel?
I'll make them unlisted, like, so you won't be able to find them, but I'll send them all to your
So
email.
what if it's beneficial to students all over?
But then teachers are gonna copy his amazing work.
And they can make my crane. They
It's
can
not my
do my
work.
crane.
I'm simply presenting the material that has been discovered by genius people like
In a unique way.
you
You technically had it.
Like, who did you say?
Euclid.
Oh, that's awesome. Yes.
Like, technically teaching, you can patent the way you teach. Because it's like your own unique style.
Technically, intellectual property. All right, so Juliet, 632 divided by 4 is 150, no remainder. So if it's 0 remainder, that means it's what? I to the 632 is
Make 632 divided by 4 is 158.
158, yeah.
Yeah, but that's the remainder, so therefore it's 4.
So it's 1, right?
Oh, like,
Good.
I'm not
Good job.
but I'm
All right. So that's that.
Not that bad.
Okay.
I mean, English kind of low.
Complex numbers. All right. What's the standard form of a complex number?
A plus bi.
Yes.
Right.
Oh,
A complex number has both a real component and an imaginary component. Okay? But it doesn't always necessarily have to be that way. Okay? Complex numbers, real, imaginary. But you could say the set of complex numbers includes 3. Why? Because A plus BI means B could be 0. Right? A could be 0. Does that make sense?
yeah.
So it could be imaginary or just real, right? But the real component is A, the imaginary component is B. Got it? If I have something like this, 2 plus 3i over 4 minus 2i, how do I get that into standard form?
Multiply by conjugate. Plus 2i.
Multiply by the conjugate of the denominator, right? So I multiply by 4 plus 2i over 4 plus 2i. Now, the top I just FOIL, right? So it's 2 times 4 is 8, plus 2 times 2i is 4i, plus 3i times 4 is 12i, plus 3i times 2i is 6i squared, right?
Mm-hmm.
But the bottom, I could FOIL, but I have something that helps me, right?
First and last.
A minus b times a plus b is equal to what?
A plus b squared.
A squared minus b squared, right? So it'll be what? 4 squared minus 2i squared. Is that right?
Mm-hmm.
Okay.
Can you further simplify that?
So now we simplify, right? A plus 4i plus 12i is a 8, I apologize, plus 16i. What's I squared?
-4. -1. I mean.
-1. So I squared is -1 times 6 is -6. Okay? 4 squared on the bottom is 16. Minus, the squared applies to both the 2 and the I. So minus 2 squared times I squared, right? I continue simplifying. 8 minus 6 is 2 plus 16i all over 16 minus 2 squared is 4. I squared is what?
Negative.
-1, so it's minus and negative, so that's a positive. So this equals 2 plus 16i over 20. All right? To finish it up, James, if you want, you can. All right? To finish it up, I just split the fraction. Okay, so it becomes 2 over 20 plus 16 over 20i. And then the last thing I do is simplify. 2 over 20 becomes 1 over 10. 16 over 20 becomes what? 4 over 5. 4 over 5i. That's all she wrote. Just remember that Thanksgiving review package that I gave you is a really good review for this exam. Okay. And all of your previous exams are very good, and your notes. Those are the 3 things that I would highly recommend you study from. Other than that, your newest book for the most recent material. And there's some stuff in the older book as well, though it is a little bit more difficult to elucidate the lessons.
Big word, big word.
Big word here. Okay. Good. Next. Any questions on this? No? That was good? Yeah? Okay. Quadratic equation. Alright, standard form quadratic equation is ax squared plus bx plus c. If I'm solving for 0, then x equals what? Negative b plus or minus square root b squared minus 4ac all over 2a. Good job. Now, let's say I end up with something like this, right? I think you all pretty much know the quadratic equation by now. I'm not going to go into actually going forth and solving one, because let's say I end up with something like this. X equals 2 plus or minus radical 40 over 2. And I say to you, simplify completely. Is that fully simplified?
No, it's 1,
2.
I'm not gonna say
How do I?
2 radical 10.
I need to get that radical, right? So square root of 40 can be split up to square root of 4 times 10. Why would I take a 4 out?
Because
Because it's a perfect square. So this becomes square root of 4 times square root of 10, right? Because I can split the square roots, which equals 2 radical 10. Is that right? Yeah?
Yeah.
I think so. All right, 2 plus or minus 2 radical 10 over 2. Right? So I have a shared 2 on the top. So what can I do with the 2's? Cancel them all out, and I'm left with what? 1 plus or minus radical 10. All right? What about if I had something like this? What about if I had x plus, or what if I had 1 plus 2, just say I had 1 plus or minus 2 over 2. Could I cancel these 2's out? No. No.
No.
Bad.
No.
Bad. Right? This is my like little spray bottle. Apparently Miss Brault had a good way to do it, to remind, and so I'm going to steal this. Thanks, Miss Brault.
Why not?
She said, I learned this from my first hour class, that these two are married and you can't take from one without taking from the other.
Oh,
I always
that's
use
good.
that. She's
Yeah, marriage. Like, did she have a rough marriage?
Okay,
Whoa.
so, right? So you can't take from one without taking from the other. So I can't take from this without taking from this. Got it? All right. Because a married couple shares everything.
Except 2.
Except the two.
That's not okay.
Except for
A toothbrush.
Can't share 2.
Or candy.
It's disgusting. I mean, you could, but
my friend once
Have you-
used my toothbrush when I was in like middle school.
What?
And I was like, it's okay. And my mom saw it and she was like, you need to disinfect that, right?
Disinfect?
Maybe
Throw it
put
away.
rubbing alcohol.
I would have thrown it away.
Yeah, we
I
got
wouldn't
care.
throw it away.
Look, there are a lot more gross things that like 10-year-old boys do, like dig in the mud and
That's no.
No,
Digging in
it's
the
not
mud
the
is
same.
not.
frogs.
No. That's
No.
not as gross as digging into
I guess, whatever.
No.
Fine. Clearly, I'm still hurt by this incident.
It was traumatizing.
Yeah,
It's
right.
funny, it's
Yeah,
funny how
no.
things last in your memory, though, right? Like specific things you'll remember, and other things just completely disappear.
Yeah, like all the answers to the test, I can't remember.
Right?
Useless junk.
Imagine if you
I know that, but-
see, all you have to do is traumatize yourself enough with
Oh.
the math,
With the math.
and then you'll always remember it.
Yay.
See?
That actually did happen to me in geography. I was so traumatized.
Oh my
You're
goodness.
so traumatized that you can't forget it ever.
Yeah, that I cannot forget.
I will never forget algebra. All right, good. Completing the square. So, if I have f of x equals x squared plus 6x minus 10. Okay, how do I complete the square?
Minus
Bring down 6, divide by 2. and
So step by step,
Mine's it.
I rewrite the function until this point, to the middle term. I take this number, I divide it by 2, and I square it. So 6 divided by 2 is 3, 3
9.
squared is 9. So I add 9, and then I have minus 10, but I added 9, so what do I have to do?
Subtract.
Subtract 9. That makes sense?
Yes.
Okay. I put this bit in parentheses. This then becomes what?
X squared plus
X plus
X plus
3. How do I get 3?
3. From that.
The number that's in the parentheses. Very good. 3 squared. Then I have minus 10 minus 9. Oh, I didn't want to do that. Let's make it plus 10. It's just a quick, you just add another line.
Now it's not minus 19.
No, it's not minus 19. That's what you get for going ahead, Simon.
I didn't write it
Make
down.
another crane.
I can't wait. I'm
That's a
actually
punishment for everything.
I'm preparing like
That's
the
why
papers.
Asians are so good at origami.
Like, I'm actually preparing the papers to like.
Okay.
B plus.
Plus
Maybe
10.
50.
Plus 10 minus 9 is what? Plus 1.
For each point.
Okay? You have now completed the square. Right? Is that good? You understand how to complete a square?
Yeah.
Now, what would this be, this equation? What shape would it look like?
Parabola.
It's a parabola, right? So if this is a parabola, if this is a parabola, then this right here is also a parabola, but what form of the equation is this?
It's a correct one, vertical.
Standard form.
Oh, I mean, yeah, standard form, that works too.
We created the standard form of the parabola by completing the square.
What's the standard one?
The standard form of a parabola is x minus h squared plus k, where h and k are what? The vertex. So the vertex of this parabola would be where? -3, 1. Got it? So not only did we just do completing the square, but we also did the standard form of a parabola and also finding the vertex of a parabola. Okay? So we kind of skipped around a little bit there, but we found the vertex of a parabola. Good. Now, what do I do if I want to find the zeros of a parabola?
Solve for x.
Solve for x by setting this equal to what?
0.
0. So I do x plus 3 squared plus 1 equals 0, right? Then what do I do?
Subtract the 1.
Subtract 1. And I get x plus 3 squared equals -1. Then what do I do?
Square root.
Square root both sides, right? That cancels out. I get x plus 3 equals plus or minus. What's the square root of -1? I. Very good. Then what do I do?
Subtract 3.
Subtract 3. X equals -3 plus or minus I. So, are those real roots?
No.
No. So what does that tell us?
Doesn't touch
That it
the
doesn't
x.
touch the.
It doesn't touch the x-axis. Very good. So if my vertex is here at -3, 1, right? Zooming forward a little bit, this is a parabola. What's the leading coefficient?
1.
1, positive or negative?
Positive.
Is this an even or an odd function?
Even.
They're both going
Even. So they both go up, right? So my end behavior is like this, right? Does that cross the x-axis anywhere?
No.
No. So we can see why it doesn't have any real zeros. Or only imaginary. They're complex zeros. So we just covered completing the square, finding the vertex of a parabola, finding the zeros of a parabola, graphing a parabola, and standard form of a parabola. All the way up to 16 in that one question.
Wow. We're
Right?
making good progress.
Good progress.
Good progress.
I already have 3 papers.
You know what I have? No papers.
Oh, I only have 2.
I have 1. So I have
Well, once I put my signature on it, in a spot that I'm pretty sure will come on the screen.
I could only imagine.
Okay. Next. Points of intersection of a system of equations.
Ooh, it's fun.
Okay. if I have something like
Like.
f of x, and I'm making this up as I go, so just, fine. X squared plus, who knows how this is going to turn out? X squared plus 4x plus I should make it easy on myself. Plus 4. Okay? And then I have another function, g of x equals negative x.
Wow. Wow.
Right? And I want to find the points of intersection. Of these two functions. What do I need to do? I could do that, but then that would be like a composite. Well, yeah, we did. That would be a composite function, right? We know composite functions, but we don't want the composite function here. We don't want f of g of x. What do we do? If I want to find the points of intersection, inherently, if I'm saying, or implicitly, or definitively, when I say the points of intersection, that's where they're equal. So what should I do? Set them equal. I set f of x equal to g of x, right? Yeah. So I get x squared plus 4x plus 4 equals.
Double. 2 times in 1 day. Oh. Wait, Lean.
Ben is next grade. Sorry.
It's alright. You're welcome. Okay. Set them equal to each other.
1 day. Sorry.
Okay.
School.
And then what do I do?
Add the x.
Right? I should probably add the x to both sides. Right? Because I don't know how to do it otherwise. So I should probably get 0 on both sides. So I get x squared plus 5x plus 4 equals 0.
X
And
plus 1.
X plus 1 times x plus 4. Very good. So, the points of intersection are at x equals what?
-1
and -4, right? So, now, here's the thing. How can I find the y values very quickly?
0. I mean 4. I mean input 0 into x.
What?
X plus 1 equals 0.
What are you saying?
I have my x's -1 and -4. How do I know what my y values are?
Make one
Wait,
of them
plug that
negative.
into that.
Make one of them
negative
0.
Plug it in. Should I plug it in here?
No, the other one.
Plug it in here,
That's
right?
what I said.
How do I,
That's not
how do
what
I
you
know
said.
that they're the same? How do I know that they're the same?
Because
Because
they're
Set
equal
them
to each
equal
other.
to each other.
that's right, because I already set them equal. That's their point of intersection, right? So my first point is -1, and if g of x is negative x, it's 1. And second point is -4.
I'm clearly having
Thank you. -4, 4. Okay. Once I've got that, I now create my graph, right?
Yeah.
So,
You have a regular parabolic thing.
You look like
two
a
to the
regular
left.
parabolic thing with 2 to the left.
Well,
okay. So, I have 2 points of intersection, -1, 1, and -4, 4. I can pretty easily draw my line, right? G equals -x, that's just this guy right here, right? Now the parabola is a little bit different, right? In order to graph the parabola in a good way, what do I need to find?
The
X
vertex.
plus
The
no.
So you gotta
vertex,
complete the
right?
square.
So I complete the square, x squared plus 4x plus 4, or I write it just to 4x, right? Divide this by 2, 4 over 2 squared. So if x squared plus 4x, divide the 4 by 2, I get 2. 2 squared is 4. If I have plus 4, oh wait, that's already a perfect square.
Right.
Yeah, it's x plus 2 squared.
It's just x plus 2 squared, right? That's
So
just
now
x,
it's a bad day.
x
Oh.
plus 2 squared, right? Okay, so standard form of a parabola is x minus h squared plus k. So h is what?
Negative 2.
-2 and k is 0, right? So I know my vertex is at -2, 0. Very good. Now, let's say I want to solve for my zeros of this function, okay? It doesn't work out so well because it's already a perfect square, but if I wanted to solve for the zeros, I do what? X plus 2 squared equals 0, right?
Yeah.
And I take the square root of both sides, and I get x plus 2 equals 0. Is that right?
Mm-hmm. See, senor.
You're very right.
So subtract 2x equals -2. So my 0 is at -2, which is the point that I already have, right? Okay, but I just wanted to go through that process again, because that would be necessary if it wasn't already a perfect square.
That's a good idea for a pi day. Make sure that's an hour pi.
They exist.
Okay. Last thing that we can do. What's one more thing that we can do that's easy, just to graph our parabola? Something that's very simple.
Oh, do the 1 through 5. The 1 through 5.
The table.
Plug-in points, like a table.
The 1 through 5 thing.
That we could, but
The 1 through 5
A table.
the table, that's what Juliet was just suggesting. But there's one specific point that's very easy to find.
The one.
0.
The what?
What?
The y-intercept.
Okay.
Well, how do I find the y-intercept? Plug in 0, I plug in 0, I get 4,
I'm
right?
having a good day right now.
So there you go. Here's my y-intercept. And I know it intersects my line at the 2 points that I found. There you go. Okay? So, for the record, in this one question now, not only did we do graphing a system of equations, but we did everything, points of intersection of a system of equations, and all the other things we did before.
Yeah,
Right?
yeah, 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 yeah.
So we just did 12 through 18 in one problem.
Oof, we're good.
Ooh, we're good.
Okay? Very good.
Also, to hang up the crane, if you have like a needle, you can stick it to the bottom. There's a hole at the bottom. You can stick it through, and like it'll end up on top. So you put like a thread or something. So it's
Yeah, I
like-
just hung it from the tail.
Yeah.
And it makes it look like it's flying a little bit.
Oh
Swoop it.
yeah. Oh yeah.
So glad this is all in the video. Forever ingrained in the memory.
I mean, you have to decorate your room one way.
Yeah, it has that shark.
I do. I tried putting a dolphin up, but it kept falling down. So
Oh.
I think I really want to hang them. Actually, I don't want them to just be so static. I kind of want them maybe put them by the air conditioning so they
Make a
kind of
mobile.
flow a little bit. All right. Next,
This room is great about this.
graphing a cubic function.
How to graph the cubes. That's a misleading name. I thought we were going to be graphing like cubes.
It's like some American endeavor. It's like I'm gonna do it.
Oh, this is so long.
Okay. So, remember this form, or plus, I guess it could be plus k, but either way, I might have my letters incorrect here. Did you guys remember this form? We covered
Yeah,
this.
here's
What was that?
H and K.
It was H and K, right? Yeah. Right? Okay. You guys remember this? This is a little murky. It's okay. What was that?
Isn't there a P in there?
That was parabolic. That was standard. That was regular form of parabolic thing, or in a circle. You know for the dielectric and the thingbobber, and P was the distance between the two and the vertex.
Yeah.
Yeah.
Oh, actually, yeah, we need to cover that. I just
Yeah, we
thought graphing a parabola. We need to cover that as well. The vertex and the directrix. Thank you.
And the focus. That's what's called the focus.
Focus. It's okay.
You get that
Um,
Yeah, can we cover that first? Because
Thank you.
we're like, I'm shaking on this too.
This stuff. Well, let's just cover this for now, and then we'll go back because while this is kind of in our head, because this is actually pretty straightforward. All right. A cubic function just looks like this. All right. That's what a cubic function looks like. For a standard cubic function, this would just be f of x equals x cubed. So a here is equal to 1, h here is equal to 0, and k is also equal to 0. H and k are the point in the middle there. All right? So when I think of h and k, I think of how much I'm shifting that middle point. All right? So if I have some g of x equals 2 times x minus 2 cubed plus 3, let's say. Okay? The vertex will be at where?
2, 3.
2, 3, right? So it'll be here. Now the only other thing you have to remember, so that's very straightforward, right? You're just shifting. The only other thing that you have to remember when you're graphing this is, first is just the general shape, right? And if this was negative, what would happen?
It would go from top to bottom.
It would flip over, right? It would just flip over.
Yeah.
Right? The vertex would stay in the same place, it would just flip it. Okay? If it was negative. Alright? The only other thing to remember is with x cubed, I go over 1, up 1, and to the left 1, down 1. Okay? This regular function is just 1, 1, and negative 1, negative 1. Okay? So to plot this, now all I do is I stretch this by a factor of 2. So I go over 1, up how many?
2.
2. Right? And I go over to the left 1 and down 2. Right? Just like that. Okay? And I'm not going to be looking for zeros or anything. Chances are I'll give you a multiple choice question with this, where you'll have different graphs and I'll say, which is the correct graph of this function? And you'll have to be able to determine that. What's that?
I said cool.
Oh, you said cool.
Okay.
You know what? Stay quiet.
Yeah.
My rubber band is like whipped onto my tongue.
Now, I have to look up the equations just to make sure I don't make a mistake. For our next one, we'll do graphing a parabola. Okay, does everyone understand this? We covered this very lightly.
I semi get it, like not almost.
It's very straightforward though. It's the exact same way that we're used to with a parabola, except we have h and k shifting this middle point instead of the vertex, right? And then all you have to remember is this stretching component. Just all you have to do is instead of going over 1, up 1, you go over 1, up however many this is, right? If this is 1/2, then you go up 1/2, right? If it's -2, you go over 1, down 2. Got it? Okay. And like I said, it'll be a multiple choice one, so you're just gonna have to be able to say, ah, it's that one.
You should make everything multiple choice.
Okay.
Really?
Of course not.
Like, really? Oh. Let me try it first.
I resisted an opportunity to be evil in first hour, so I couldn't resist that one. So you gotta be bound.
Resisted an opportunity to what? Wait, what was the
No,
evil
someone asked me if they could have like a cheat sheet on the exam,
Hey, what's your
and I was
first
like, let me think about it. And I had such an inclination to be like, but let's get it.
Wait, what's your first?
So what'd you do?
first hour?
Because you had to tell him no.
Got this.
Oh.
Oh, okay.
I've been like, yeah.
Wait, but so what'd you say? Because you obviously said no. Like,
Yeah, I said no, but
Oh,
I actually considered it rather than completely dismissing it outright. So, graphing a parabola. Parabola.
So why can't we have a cheat sheet? This class is giving us cheat sheets.
You don't need to cheat sheet for that.
Dr. Waldron, that's it.
You don't need cheat sheets in math class.
Yes, we do. There's a lot of formulas.
No, I mean, no. There's not
Not
really.
really.
There's
Like 3, 4.
only a few.
No,
You already-
that
you
that
already
whole
know the
list of
quadratic formula.
of
So,
the ones.
graphing a parabola, x minus h squared equals 4p times y minus k, or y minus h squared, or y minus k squared equals 4p times x minus
The first one's for horizontal, right?
h.
Vertical. Like,
Ah.
wait, vertical like
First
this?
one is horizontal.
Wait, vertical like this or?
The y less grades is
Let's see, I'm squaring a y. I have y squared, remember? Remember from our determining whether or not something is a function, right? No, we can do that. If I have a y squared term, like if I have y squared, this is the easiest way to remember it. If I have y squared equals x, then y equals plus or minus radical x, right? Which would be something like this, right?
Yeah.
And if I have y equals, look here, the easiest really way to remember is like, oh, that's an x squared. Oh, then y equals x squared. That's a vertical parabola. That's the regular parabola we're used to, right? Which is, does that make sense? Okay. All right. So this, I think you guys are pretty good with.
No.
No?
I'm good.
Can do it.
That was our worst time.
Yes? No? Okay. So, H and K are what?
Vertex.
The vertex. What is P?
The distance from the directrix from the vertex and the focus.
Distance from vertex to focus and vertex to the directrix. Okay? Now, which is which? How do I know which one is which which way?
Okay, it's dependent on whether it's negative or positive, and if it's a regular vertical one, it's in the top. If it's it's in the top of it, like higher up than the vertex, and it's below it, it's the direction.
The best way, yes, the best way to remember this is that if this is positive, right? If this is positive, y equals x squared, it's up. It's upwards facing. And we know what an upwards facing parabola looks like. It looks like that, right? And so the focus will be the vertex plus p, right? And the directrix will be the vertex minus p. Make sense?
Vertex plus
But the way that I suggest you remember this is you remember it conceptually. Because if you try and think, okay, this is positive, so it's vertex plus p is the focus, and then the vertex, for me that's already confusing to even have in my mind. So all I do is I figure out, well, that's positive, so it's upwards facing. And I know the focus is always in that part of the parabola, and the directrix is always on that part. So then from there I can then think, okay, well, it's got to be the vertex plus the focus, plus p, to get there. Does that make sense? To kind of just draw it out, even if you just draw a little sketch on your paper first, right? Just draw, okay, this is positive, it's got to be there. Oh, my focus is there, that's, right? Does that make sense? Okay? And if this is positive, which way am I facing?
Left.
Just
I mean
like-
right.
To the right, right? The positive direction, right? And my focus is here and here, right? So you can always think about it. I mean, it works. It's the focus is always adding to the vertex. So if you want to think about it like this, the focus equals the vertex plus P, and the directrix equals the vertex minus P. Okay? And that works whether P is positive or negative. Now, very clearly, or maybe not so clearly, let's do an example. Okay. So if I have, let's say, x minus 2 squared equals 4 times y minus 3. Okay. Let's find all the things first, and then we'll graph. Okay. This is what I do. All right. Is this a vertical or a horizontal?
Vertical.
Vertical. Is it upwards facing or downwards facing?
Up.
Okay, so now on my paper, I draw that. Now I've got a visual, right? And then I draw this. I put a little point and I put a little directrix. Oh, I'm basically halfway there, right? Okay, so now I say, where is my vertex, for instance, I would say?
2,
Vertex would be at what?
2, 3.
2, 3, right? Okay, what's my P? P is 1. My focus, let's see, it's positive, okay, it's up, I'm adding, vertex plus P, focus is vertex, whichever way you want to remember it, it's vertex plus P. But do I just add 1 to both, so it's 3, 4? No. How do I know which one I added to? The one that goes up and down, the vertical, right? So
2, 4.
2, 4. The way you can remember it is if it's a vertical parabola, I'm adding or subtracting P to the vertical axis, right? So it would be 2, 4 is my focus. Now, my directrix is what?
2, 2.
That would certainly be a point on the directrix, but is the directrix a point
No,
or
line.
a line?
Y equals
Y
2.
equals Y.
As y equals 2, right? Because I have 3 minus 1 is 2, so my directrix is at y equals 2. Okay? And you can rest assured that if I give you something like this, I'm not going to then also ask you to graph the parabola, right? I could, but I could maybe, if anything, I would say, I wouldn't ask you to specifically graph it, I'd give you graphs, okay? And you choose from them. Does that make sense? Okay, so, but let's see if we can graph this, right? Our vertex is at 2, 3. Our vertex is at 2, 3. It's upward facing. I know it's upward facing, right? So I'm just going to draw it like this. I'm not going to care about where the y-intercept is right now. I'm not going to think about that. I'm just going to, give it a gradual idea, right? The directrix is at y equals 2, so that's here. This is my directrix. And my focus is at 2, 4, which is that point right there. Okay? All right. So obviously the same rules apply for a horizontal facing parabola. It's just the horizontal version. All right. So very good. Please review the study guide tonight when you go home. We've finished up to number 20. So we only have 21 to 31 to cover still. And that's the stuff that's fairly recent, except for solving a system of 3 equations. The other stuff, binomial theorem and stuff, that's pretty recent stuff you've been tested on.
I have 4 pages now.
What was that?
I have 4 pages.
I have 0.
4 pages of review?
Yeah, but like, I'm doing small though. Like I'm rating, and like I'm lining up the spot like of where the circle, like what I have to cut out, and I'm only rating there. So the circle shorter than.
Cool. Should give like extra credit points for those who take really good notes, and then I can
Training.
take them and copy them, make copies, and then I can just teach off of them next week.
Or if you make rings.
Right, there you go. Nice haircut. DB.
That's
Nickname.
you would have called me that before.
Good job today. How's everything going, Emily?
Pretty good.
Yeah?
Yep.
Understanding more material?
Yeah, I get it now.
It's funny, right? You guys, I feel like you guys learned a lot, right?
We did.
Right? But now reviewing, it's like, yeah, I get stuff.
Did you stop the recording?
Oh, probably should do that.